In this video, we're going to be talking about inequalities in triangles. We're just going to do a short part of it today, and then we'll hit the rest of it later. It says, look at the triangle to the right. The sides of the triangle are given. Can you determine which is the largest angle? So by looking at the triangle, if I had to make my guess, I would say that this is the largest angle because it looks like it's obtuse, and I can tell that the others are acute. As you might guess, the largest angle will be opposite of the side, that is 18. Similarly, the smallest angle, which I think is this one, is opposite the smallest side. And then that means the middle side, middle length side will be across. So there's this relationship. The side across from the angle does determine its rank within the triangle as far as angles go. And that's what these two theorems say here. One of them is theorem 5.9. If one side of a triangle is longer than another side, then the angle opposite the longer side will be larger than the angle opposite the shorter side. One way of thinking of that is the angle, if you think of it as like a mouth, it kind of eats that other side. And so if the side is longer, then that angle is going to have to open wider, but if it's a short side, then it's only going to have to open, so far. So as this distance between my fingertips increases, the angle will in fact get larger. And then the converse of that is also true, which means if we flip it around and we say, well, this angle is larger than another angle, then that means that side opposite the larger angle would be longer than the side opposite smaller angle. So here it says, list the sides in order from shortest to longest. Well, in order to do this, we're going to need to know the measures of the angles. And I see we have 86, and we also have 27, but I don't have this third angle. So I'm going to use triangle sums to figure out the measure of angle A. 86 plus 27 plus the measure of angle A must equal 180. If I simplify here, I get 113. And then I would subtract 113 from both sides, and I would get 67 degrees. So angle A is no longer a mystery anymore. Now that I have those three angles, I'm going to list those three angles in order from smallest to largest. And so I'm going to put 27, then I'm going to put 67, and then I'm going to put 86. What this does is it gives me my order. Since those are the numbers I'm going to be using, I just need to associate the side with that angle. And 27 is associated with AB. So that means AB is the shortest side. 67 is associated with the side opposite of it, which is BC. And lastly, 86 is associated with AC and is the largest of those three. So that is the order from shortest to longest, listing the sides. Let's go to the next example here. List the angles in order from largest to smallest. We have 4, 5, and 6. Largest to smallest, though, would be 6, 5, 4. But this isn't the answer. Those are the lengths of the sides. They want the angles. So what I'm going to do is I'm going to pick the angle that is across from side 6, or the side that has a length of 6, which is angle A. Then I would do the same thing with 5, which is angle B. And that leaves nothing but angle C, which is across from the shortest side. And so in order from largest to smallest, angle A, angle B, angle C. This last part is talking about triangle inequalities. Not just any 3 segment lengths can create a triangle. In this example here, it shows that the length of 4 and the length of 5, they won't reach across that gap. And that's because they're not long enough. 10 is longer than the sum of 4 and 5. But even if we extended this and we said, oh, well, this one is now not 4, but it's 5, they still wouldn't reach, because we know the shortest distance between any 2 points is a straight line. Well, that is right there, 10. Well, if I'm going to have some angles here and make those come up any at all, okay, if those were doors to a cabinet, the moment I open those doors, the cabinet doors pull apart from each other, the ends of them do. And that's, the only way they're going to touch is if they were laying flat, but then that's not a triangle. So it has to be a special relationship here. And that relationship is the sum of the lengths of any 2 sides of a triangle must be greater than the length of the third. And I'm going to simplify this a little bit, because if I use the larger side when I'm adding them together, the largest side will always add to be larger than something that's shorter than that. And I don't know if I said that very clearly, but what I mean is we don't really need to worry about the longer side. Let's just check to make sure that the 2 smaller sides will add up to be larger than the largest side. So here are 3 side lengths. Will they form a triangle, or could they form a triangle? If we had 4.1 and 3.5 and 7.5, and I'm going to add those together. I'm going to take the 2 smallest sides, I'm going to add those together. Well, that would be 4.1 and 3.5. And if I add those together, I get 7.6. Now, is 7.6 greater than the third side of 7.5? Yes, it is. And so that's a triangle. That would form a triangle. 4, 4, and 8. My largest side is 8, which means I need to see, will 4 plus 4, which is 8, be greater than 8? The answer to that is no. My largest side out of 6, 7, and 8 is 8. So if I add 6 plus 7 and get 13, is that greater than that largest side? Yes. These 2 make a triangle, but the middle one does not, because 4 plus 4 is not greater than 8. So let's look at the last part here. It says find the possible lengths of the third side of a triangle if the other 2 sides are 10 and 6, which means there's a third side we don't know. We'll call it X. Let's assume that X is not the longest. Okay, if we assume X is not the longest, it means that it's one of the 2 shorter sides. And so we would take the 2 shorter sides, 6 and X, add them together, and it has to be bigger than 10 if it's going to form a triangle. So we solve this inequality by subtracting 6 from both sides, and we find out that in order for this to work, x, or my missing side, would have to be greater than 4. Then we're going to assume that x is the longest. In this case, that means 10 and 6 are shorter than x, and so we would add 10 plus 6, and it's got to be greater than x. On this one, we just simplify the 10 plus the 6, and if I rewrite this so that x is first, it would say x is less than 16. So in the end, what we wind up with is we know our third side has to be smaller than 16, but it's also got to be greater than 4. So in between 4 and 16. The quicker way to find this is if two side lengths are a and b, then the third side would be the range, subtract a and b, it's got to be bigger than that, add a and b, it's got to be smaller than that. So if my two side lengths are 10 and 6, all you do is this. 10 minus 6 is 4. 10 plus 6 is 16. And your third side has to be between that. So that's the same answer as what we had here. And that does wrap up the quick lesson for today. If you have any questions, let me know.